Okay, so we're looking at the final depreciation method, which is reducing balance depreciation through recurrence relations. So it calculates the future value of an asset by reducing it every year by a fixed percentage of its value in the preceding year. So that's sort of similar to, remember, compounding interest. So it depreciates based on the year before or prior. So the first example we're having a look at is a business that purchased a photocopier for $10,000 in 2014. It is depreciated using reducing balance depreciation at a rate of 18% per annum. Give all answers to the nearest dollar. So copy and complete the table, which is down here, number of years, the depreciation as it happens, and the future value after so many years. So it's asking us the future value of the photocopier after 5 years. So what we can see here is that we're using 18%, so 18 over 100, and multiplying that by the initial value or the value in the prior year or the start of the year. That gives us our depreciation for that year, for year one, 1800, and we subtract that to get what the value is at the end of year one, which is 8,200. So in the second year, we instead of using the 10,000 as we did before, we're using 8,200 and multiplying that by 18 over 100, which then gives us a lower depreciation at that point, and subtracting that through. So you can see each year we're using the year before, the value of the year before, multiplying it by 18% and subtracting that depreciation from it. At the end of year 5, we'll see that that's $3,707, and you can just write a sentence stating that. So the future value after 5 years is $3,707. It also asks us the amount of depreciation. So future value is what we end up with, but the amount of depreciation is obviously in the middle column here, so how much you're actually depreciating in that 4th year. So from the table, we can find year 4, its depreciation is $992. The second part of the question asks to write down a recurrence relation that gives the value of the photocopier. So it depreciates by 18%, so therefore after each year 82% of the value remains. Now we have a starting term, which is our 10,000, and what we do find is that the next year, so the year that we're looking at, uses the year prior to it, and we multiply that by 82% because that value will be this value of this year will be 82% of the year before it. So if we use that general formula, we can start to find the future value after more years, so after 6 years, 7 years, 20 years, whatever. So in question C, it asks us, the photocopier is replaced and then its value first falls below 3,000, when its value falls below 3,000. At the end of which year will the copier be replaced? So this can be a CAS recursion or use a trial and error method. So what we find is that if you're using that general formula as we spoke about, putting all the values in as we need to, so V6, you'll find you'll use the 5th year value times that by 0.82, and you should get, so what we should have here is that 3,700. If you times that by 0.82, you should get $3,040.07. It's not quite below 3,000, so you might need to go to the 7th year, which ends up being 2,492. Now that it's below that, that is when it needs to be replaced. So if our initial year was 2014, we need to add 7 years to that. And if we add 7 years to that, in 2020, they needed to replace that copier. That's all that's saying there. So how much is the photocopier depreciated by the 6th year? we found the difference between V5 from the table, V6 we found in that previous question. So we subtract the value of year 5 from the value of year 6, value of year 6 from the value of year 5 rather, and that difference is $667. In question 8 then states to use a graph to find the photocopy's approximate value after 8 years. So you'll start to see a bit of a trend, and if we're plotting this, our initial value being 10,000, but if we're plotting our future value per year and our years down in the x-axis, you can start to see this start to trend downwards, sort of exponentially in a sense. And by year 8, if we kept extrapolating that graph, you'll see that it's around about $2,000. Here are the general formulas for that. So we subtracted that 18% from 1, which gave us that 82% of the value prior to it. So there's the recurrence relation there. And below that is our general rule or formula that we would use. So the future value is equal to the R, which is the percentage that it would be compared to number of time periods. So in the case we used was per year, so it's just 1, and the initial value or starting value there. So example 2, a truck was bought for $250,000 and is being depreciated on a reducing balance base rate of 8% per year. We use the general rule to reduce the balance depreciation after a certain number of time periods to find the truck after 9 years to the nearest dollar. So you may like to list this, so the initial value being $250,000, the number of years being 9, our rate, in a sense, is 0.92% because it's 8% taken from 100% or 1. So we've got all those values and we're looking for that future value here being Vn, or V after 9 years. So V after 9 years, if we substitute those values in, we'll put that 92% or 0.92 to the power of 9 because it's 9 years. Up here, number of years, these are the same, times by 250,000. So after 9 years, that value of the truck would be $118,040. Now, if you have a look down here, you'll just need to follow the steps on your T-Inspire CAS. So what you'll need to do is go into menu 8, which is finance, and 1 finance solver. So you may want to highlight those notes there. And you can see here as you go down finance solver, and it has those values there. So the number of years, the actual interest rate, the present value, PV, the payment, so any payments that are made, and future value, or FV, being here. So you can sort of see the fields that you'll need to enter to find your answer. You also have PPY, which is the number of payments per year. Most of them are once a year, so you may usually put 1, but if you're paying it monthly, that may be 12, quarterly, it may be 4. CPY is the number of times a year of interest it's compounded. So if it's only once a year, it's 1, 12 for 12 months, etc. The payment is when the payment is being made, the beginning or the end of time period. Depreciation occurs at the end of a time period, so leave that payment to set to the end, because usually that's when it all changes. And at the bottom of the screen, enter when the payment is made at the beginning or the end of the time. So usually depreciation will occur at the end. So try and make sure those fields are correct. You can also see, here's an example. You can see as this is filled in, the number of years being 6. So here's the example. Vince bought a car 6 years ago, so the value being 6, 26,500. Okay, so that's our the price, the value to begin with. After being depreciated on reducing balance basis, the car is now 9,000. So the future value is 9,000. So we've entered that in there. Calculate to one decimal place the percentage of the annual rate. So they're asking for the interest rate here, or the I%. So we've left that in there. And when you actually calculate it, so when they actually enter all the fields, you press enter, and you can see that that's that 16.47. Oh, sorry, it'll be 16.5 if it's to one decimal place. And there's your answer there. Okay, good luck.